Alright, we're in Geometry, Chapter 10, Section 5, Angle Relationships in Circles. This is not difficult, but it can get confusing, so pay attention. Alright, here we have a tangent and intersected chord theorem. So if let's say, I'll use the diameter as a chord as an example, okay, and I'm going to use this example, the 90-degree example a lot, because it's easy to understand. Okay, so this right here is 90 degrees, right? This arc right here is 180. So that angle down here is half of the arc. Okay, if this is 180, the angle down here is half of that is 90. So that works, doesn't matter if I tilt the tangent one way or another, I still get half the measure. So that measure down here is half the intersected arc. Alright, so if I want to find this angle measure right here, this is 130, so half of that, we get 65 degrees. Alright, and here I want 2 times this, because I know the angle, so 2 times that is 250. So, easy peasy. Moving on. Okay, we can have secants intersecting on the circle. Okay, so like this right here, they intersect on the circle, or they could intersect inside the circle or outside the circle. So we're going to look at these 3 different angle measures. What happens? What are special characteristics of these? All right, angles inside the circle. Again, I want to bring you back to the 90 degrees. Okay, so here we have 90 degrees, right? This is 90 degrees, so this arc is 90 degrees. Now, if I move this down, this arc is more than 90 degrees. But notice the opposite arc, that was also 90 degrees over here, this arc got smaller too. Okay, so as this got bigger, that got smaller by the same amount. So what happens here is this is still 90, this is still 90. This one got bigger, this one got smaller. If you average these two out, they're still 90. So this side plus that side divided by 2 is still 90. So that's how I get this measure in here, is I add these two up. So because this is 90 over here also, I could add those two up. That's 180. Divided by 2, I get this measure inside here. Right? If I make this smaller, let's say now this is 120, and this over here is now 60. Okay, well, I add those two up, I still get 180 divided by 2 gives me 90. So that's how it works. If you have these two, even if it's not intersected in the middle, okay, you take the two arcs, add them together, and take half of that. So you're averaging the arcs to get those. Now if I want this big one, I obviously have to take these arcs. Right? So the inside angles are half the sum of the intercepted arcs. Okay? Inside angles, half the sum. Inside angles, half the sum. Alright? Outside angles. So if I have an outside angle, and I'm going to use a special angle here again, I'm going to use a 45-degree angle. Right? So I want to find an outside angle. Notice these are intersecting outside here. Oh, right there. We know that that's 45 degrees, right? 45 degrees. Well, in here, I use that for a reason because then we can kind of imagine, okay, here all the way up to where it touches, I have this 90 and then another 45, right? So this is 90, that's 45 up here. This arc is 45, and this arc down here is also 45. So if I take this arc and I subtract this one, I end up with 90, right? So the right here, the 135 minus the 45 down here gives me 90. Now how do I get from 90 to a 45-degree angle? Well, I have to divide that by 2, divide it by 2, and that gives me the 45. So I take those two. If I have the outside, I take half the difference of the intercepted arc. So I take this one minus that one and divide that by 2. Half the difference. So if it's outside, half the difference. All right. Okay. A couple examples here. There we go. I want to find x. I know that these two are 130 and 156. So 130 plus 156. And then I'm going to divide that by 2. So 130 plus 156. Divide that by 2. And that gives me 143. If I'm outside, I have to find half the difference. So I'm going to take 178 minus 76 and divide that by 2. And that is 51. All right, now a circumscribed angle is if you have two tangents. So we're just touching. We're not going through the circle at all. So it's on the outside. Circumscribed angle means it goes around the outside of the circle. Okay, again, back to your 90 degrees here. All right? This right here is 90 degrees. So this arc right here. So this works the same way. It's an outside angle. You could use the difference of these two, right? Because that would still leave me with 90 degrees. Difference of the two divided by 2. Difference of the two would be 180. Divided by 2 still gives me 90. But there's a special way. You can just do 180 minus this angle right here. Okay? So minus 90, and that gives you the 90 degrees. Okay, so that's a special case. When they're both tangent, you just take 180 minus the arc that intercepts the same arc right there. Okay, so if I want to find this, I just have to do 180 minus 135, and that is 45 degrees. Okay, now over here, this one's a little bit trickier because they're not using the central angle. Okay, so we'd first have to find the central angle. 180 minus the central angle minus angle EGF is 30. Okay, so I can bring the EGF over here and subtract 30. So 180 minus 30 is EGF, which is 150. So that's 150 here. And this measure is half of that. Okay, so I have to take half of that, and that is 75. Divide that by 2, and we get 75. There you have it. Lots of fun, good times. Check in again next time for another fun lesson.